My name is Vassilis Prevelakis from TU Braunschweig, which is leading Task 1.4, Data and Application-centric Security of the CONCORDIA Project, funded by the EU Horizon 2020 program. In this video, we present three major research efforts carried out within this task. The first is Mobile Threat Modeling Framework by OsloMed and Telenor. This is followed by K-vertex cardinality constraints model for graph databases by the University of Maribor. And finally, Bridging the Gap between Certification and Software Development by the University of Milan.
My name is Bernando Santos from OsloMed, and I would like to share with all of you one of the many outcomes that Telenor and OsloMed obtained from the work done in Task 1.4 in Concordia. The Concordia Mobile Threat Modeling Framework was done under the scope of Task 2.1 and together with Ericsson and Tim with close collaboration of Siemens and Circle. The Concordia Mobile Threat Modeling Framework is a compatible combination of the Enterprise, Mobile, and ICS matrices of the MITRE ATT&CK framework. Since it's not sufficient with the current techniques, we also proposed additional ones. This is the first iteration of this framework, and its intention is to adapt and grow as we see the need to accommodate more techniques as more attacks become known. Some of its features are, like MITRE ATT&CK matrices, it is composed by tactics and techniques. However, no tactic is unique. Instead, we document an attack by phases. Attacks can be recursive as they spread to multiple devices, so we use loops to showcase this behavior. An attack documented with the Concordia framework will reflect which effects it has on devices, as well as, and alongside with, the operator's network infrastructure.
Hello, I'm Martina Šestak, and I'm a researcher and teaching assistant at the University of Maribor. Within Task 1.4, we are working on developing a comprehensive and abstract approach called K-vertex model for enforcing cardinality constraints in graph databases. One relevant domain of application for this approach is fraud detection in modern networks, where we want to harvest the benefits of graph database technology in visualizing potentially fraudulent patterns. In our approach, we first build a property graph data model to visually represent the network data stored in a graph database and extract relevant cardinality constraints which capture potentially complex fraudulent graph patterns. Next, we visualize the cardinality constraints and implement the model in a graph database. Once implemented, the model helps to prevent and detect fraudulent patterns in a graph database. For more information, please refer to our published paper. Thank you.
Hi, I'm Nicola Bena from the University of Milan, presenting our work in Task 1.4, Bridging the Gap between Certification and Software Development. The issues nowadays is that certification is not considered adequately in software development, or it is not considered at all. And this is a problem because certification can boost trustworthiness of the developed software. And so our idea is to consider instead certification requirement in advance before starting the software development process, and consider this requirement as a part of the multi-objective optimization problem solved as a genetic algorithm, as this figure shows. And this is a summary of our work.
For more information about this research, as well as the other Concordia activities, please refer to our website and our social media feeds.